we evaluated some composite trig and inverse trig functions that involved unit circle values, and then we did some that involved non-unit circle values that we could draw a picture and still figure out. And now I'm going to look at one that's not a value. X, the cosine of the arctangent of x. X is not a value, a specific value, so I'm not going to end up with a value, but what I am going to end up with is an algebraic expression with x's in it. So we're going to make some assumptions here. We're going to assume x is positive and acute so that I can draw it in a right triangle. There's a right triangle. I pick an angle for theta. I usually pick the lower right one for whatever reason. Doesn't matter. Pick either one. The arctangent of x is the angle whose tangent value is x. In order to make the tangent value of this angle be x, I'm going to need its opposite side to be x, which means its adjacent side is 1. So now the tangent of this angle is opposite over adjacent, x over 1, which is x. So we just drew the arctangent of x. Now I want the cosine of that angle. Well, the cosine is the adjacent value, the adjacent side, which we have, over the hypotenuse, which we need. We'll call it c, as in a squared plus b squared equals c squared. So c squared is the opposite side, x squared, plus the adjacent side, 1 squared. 1 squared is just 1, so. And now c not squared I can get by taking the square root of x squared plus 1. So we have an algebraic expression for the hypotenuse here. The cosine then of this angle is its adjacent side over the hypotenuse. So it's an algebraic expression for the cosine of that angle.